right, hello everybody, welcome. This is Miguel Ibarra. This is Miguel's project that he worked on as our intern, and our goal was to fabricate one part without any human interaction on the pedal with our universal robot. And so today Miguel's going to do his report out, and we're going to open up like a Q&A interactive session after where you guys can come and look at the pendant and the robot and ask whatever questions you got. So, here you go, Miguel.
So I'm a senior in mechanical engineering at San Jose State, and my internship project was the robotic arm. So the goal for this project was to be able to program the pedal to fabricate a bayonet, and also to program the robot to be able to feed bayonets into the pedal. Why we chose the UR10 was, so the company we bought the robot from had 3 models, the UR3, 5, and 10. We chose the 10 because it was the largest model they had, and it had a reach of 1 meter with a payload capacity of 22 pounds, which was perfect for the task we wanted it to perform. So some of the important concepts that we learned throughout the way was choosing to fabricate the bayonet because it was currently being outsourced to other companies to fabricate, so we brought it in-house to be fabricated here. Leveraging the robot's capabilities to work on the pedal, since the pedal wasn't being used as much throughout the week, it was a perfect machine to use the robot on. So deciding the positioning and the setting of the robot was also a really important part in the project, because every time you set up the robot, if it's not in the exact same spot as last time, it'll affect the positioning of the part when it places it into the pedal. So to handle that, we made holes in the ground with concrete sleeves, steel sleeves, so that way when we push the safety pins on the ground, it'll always be in the exact same spot. Once that was done, I had to create a setup mount for the bayonet to be placed inside the pedal. For that, I designed bayonet mounts for the robot to be placed in. They were 3D printed in the Laverne office with their 3D printer. So over there you can see different models that I've had as I prototyped to which one would work the best for us. And then once I had successfully programmed the pedal and the robot, I created a standardized worksheet, so anybody else who wanted to continue working on the robot after I was gone, they could follow my standardized worksheet instructions and be able to carry on. And then some of the lessons we learned throughout the programming was whenever the robot would do movements like opening the doors, pushing the buttons, or picking up the part, we created sub-programs for those movements specifically. That way when it would come back to debugging the program, you could suppress all the other movements you didn't want and just focus on, just run the program, just run the movements that you wanted to check on to see if they were working properly or not, rather than having to repeat the whole program from the beginning each time. Another thing that we encountered was protective stops. So a robot is designed to work with people, so you could be standing next to it while it's working and not have to worry about it like hitting you and maybe like breaking bone, like other robots have issues with. So one issue that we had with that was when it came to opening the doors, it would bump into the door, it would hit the door thinking it was a person, and it would do a protective stop where it would just stop working until the operator would enable it again to continue working. So we were able to overcome that by reducing the speed of the robot when it came in, so that way it would just be like a gentle push rather than a sudden like coming in hard, kind of like bumping the door. So another issue we had was the singularities. So the robot can move 360 degrees and counterclockwise and clockwise, except whenever it crosses these imaginary axes right here. It's a singularity point where the robot doesn't know how to go across that point. Like it doesn't know how much velocity and acceleration it needs to tell itself to cross that path. So the way to overcome that is to need to set intermediate waypoints in between to guide it, or else it'll just get stuck and it'll fall on itself because it doesn't know how fast to go. So once we had overcome that, we were able to successfully run the part. So the next steps for the project will be assembling a team that will be able to continue the momentum now that my internship is over. And then we also want to use a Modbus connection that will be able to talk to the pedal directly without needing to use pushing the buttons. That will make it more efficient and a lot smoother when it's running the program. So the next step we also have is creating a feeding system for the Fidal. That way it can be running continuously non-stop without someone having to put a part every single time. And then we also hope to fabricate hook lugs and other parts as well in the future. And then, so now I'm gonna show you the program. That was good. So, any questions?
Is it timed when it knows how long it takes for that thing to run, or does that machine tell that machine it's ready to get taken out?
So currently I have it set as a timer.
Repeat the question.
So his question was, is the robot timed, or does the Fidal tell it like when to go? So I programmed it to be timed, so I had to time the machine to see how long it took it to run, and then I told the robot to wait that many seconds.
Tell them about Modbus.
Yeah, so if we're like the next step is connecting it to Modbus, and Modbus uses a digital connection through the control box and connect it to the back of the Fidal, and that way the robot will be able to send digital signals to the Fidal saying, oh, it's ready to run, and when it's done too. So that way it won't have to push the buttons, which will make it a lot faster.
Training. Tell about the training.
Yeah. So in order to get trained for the robot, I took an online class that was provided by. I was on the Universal Robotics website. It was a 90-minute course. I did that online, and then I did a full day of training at Olympus Controls' office where we bought the robot from. And there I learned how to program the robot, and then we had a second half-day training where applications engineer came here and he showed me how to optimize the program and add blends. That way, when it would do movements, it would swiftly connect the movements rather than being do a movement, stop, do the next movement, stop. And once he showed me how to optimize it, we were able to decrease fabbing time from 5 minutes to 2 minutes and 30 seconds, which is really good. Thank you.
All right, yeah, so just want to acknowledge Miguel did a really awesome job for us. He did it in about 12 weeks or so. He came in with zero knowledge about robots or Fadal. We didn't even have the robot when he started. We had to go through, like, bring in the sales rep and demonstrate, and then everything from there on was just a discovery, kind of experiment, discover, experiment, discover. And he did a really awesome job. Our goal was to fab one part without human interaction, and we completed it about a week or two ago. And there's plenty of possibilities with this. There's a plethora of options for the tools. You can get some with cameras or drill bits. They could be on the, screwing the units together. And like Miguel mentioned, these are very collaborative with humans. Any sensitive thing that it touches that it doesn't expect to touch, it'll just stop and it won't do anything until you override the command on the pendant. And yeah, our hardest part was actually programming the Fadal. We don't have any internal resources with a vast amount of knowledge of the Fadal. So we looked at doing our fabrication on the Fadal through Inventor, because Inventor had a G-code, which is what the language is of this Fadal machine. And when we exported the G-code, we found out that it wasn't, the G-code coming out of Inventor was too modern for our system, so there was a lot of diagnosis of Miguel having to go line by line in this code and figure out what's needed and what's not needed to get it to work. So all in all, I mean, 12 weeks, he did this with no experience. It's a really awesome job, and I just want to give you another round of applause for that.